Lesson 32, Unit 7.1, we're going to be working with monomials and factoring. Key terms, factored form. Factored form is a monomial expressed as a product of prime numbers and variables in which no variable has an exponent greater than 1. Greatest common factor, also known as GCF, that is the product of the prime numbers, factors common to 2 or more integers. Example 1, we are going to take monomials and put these things into factored form. So we have negative 25 x to the third y to the second. Remember, when putting things in factored form, we want to have prime numbers. A prime number is a number that only 1 in itself, so a number that's divisible by 1 in itself. The exponents cannot be greater than 1. As you notice on the problem here, we have exponents greater than 1. So when putting things in factored form, the first thing that we'd maybe want to do here is take care of the numerical value first. Take out a negative 1. Get rid of your negative. When you get rid of the negative, you'd be left with 25. Prime number that can go into that would be 5. So I'd factor out a 5. You'd be remaining with 5 x to the third y to the second. So we're able to factor out another 5. When you break x to the third down, basically that is 3 x's. And then we'd lastly factor out our y's. Y squared would give us 2y's. This is what your answer would be in factored form. Example 2, same situation here. It is an even number. You can factor out a 2. Again, you want to start with your smaller prime numbers first. We know a 3 can go in there, but start with 2. Factor out a 2. From there, we're able to factor out a number 2, another 2, and a 3, another 3, followed by 2 a's and a b. When you multiply all this together, 2 times 2 times 3 times 3 times a times b, you would come up with 36, a to the second b. What I would like you to do now is the skills check. Go ahead, pause the computer right now, and work through example C and D for the skills check. All right, now that you're back, go ahead. You should have factored C and D. Factored form for C, you'd wind up with this as your answer. Double check yours. And D, remember we're able to factor out that negative, so we'd factor out that negative 1 first. And this would be your 2 answers in factored form. In example 2, we're going to be finding the greatest common factor of a set of monomials. Remember, when finding the greatest common factor, it is a product of 2 or more integers here. Basically what I did right away is I took 21 and 49 and did what we did in example 1. I put them in factored form. Looking at these 2 in factored form, you would find out that they do have something in common. 21 you have 3 and 7, and 49 you have 7 and 7. So both 21 and 49 both have a common factor, both common factor of 7. That being our only common factor, our greatest common factor is 7. Our greatest common factor is 7. In example B, same situation here. Go ahead and put your 2 in factored form. So putting 12 a to the second, b to the second, c in factored form would look like this. 18 a b to the third in factored form. Look something like that. From here we are able to pair up things that they have in common to find our greatest common factor. You would see that it has a 2. They would also have a 3 in common. Each monomial also has an a. And if you look at both, both would actually have 2 b's. Here's a b. Here's another b that we could take from both of them. What's remaining up here on top, you have 2ac on the bottom, you have 3b, so there's nothing else that aligns with each other. So when we multiply this out, you have 2 times 3 is 6. times A is 6A, times B, which is 6AB, times B again, and you would wind up with 6AB to the second. That would be your greatest common factor. Go ahead, pause it, work through C and D to find your greatest common factor of each of these pairs of monomials. Now that you're back, you probably did the same technique above. You should have wound up with a greatest common factor of 6y in C, and for D, you should have wound up with a greatest common factor of 10ABC. This concludes lesson 32.7.1.